Hi, Miss. My name is Benjamin Yek Ethan. My student ID is 10276590 And now today, I'm going to present about the presentation of my Applied Machine Learning Assignment 1, which is bird-specific classification. Okay, so this is the table of contents, which I will give an overview to our today's presentation. So first of all, we'll talk about the introduction, about the data sets and the model I use, and the key concepts, which is the data pre-processing and model architectures, and also the results. And we are going to talk about the problems, what's the overfitting issues I encounter, and how do I solve it. And then lastly, I will show about the outputs of my code and the report briefly. All right, so now I will talk about the introduction. First of all, in this training, the assignment, the dataset that I chosen to use is Caltech UCSD bugs 200, which the code CUB 200. And this is a multi-class classification which contains of 200 bird species, which 200 different types of bird. And also I got a 4,829 training image for me to train the model, and also the 1,200 0.404 testing image to validate the accuracy. So now I will talk briefly about the CNN model that I use in this assignment. So first of all, convolutional neural network is a model which for the image classification. So for example, when I put an image into it, for the input layer, when there's a visible layer, so I can, for example, the convolution layer, switch also the max pooling layer, and also something like batch normalization layer that I can use. So after the input, go through the input layer, when it comes to the hidden layer, for example, the dense layer, so there's the hidden layer that I cannot find where the neuron, where the how the image can process in on the hidden layer. So after the hidden layer, go to the output layers, and then after you go through all the inputs, hidden and output layer, so it can predict the accuracy or which this input image is bird or dog or cat. Yeah. So I will talk about the key concepts that I use in this assignment. First of all, for the data pre-processing step, I import all the used libraries, and also I unzip the data set from the Google Drive. And then after I unzip and extract all the data sets from the image, and then I can reset. I do the normalization function to reshape or resize the image. And after I get the rescaled image, I convert it into the list, and then I convert the Python list into the NumPy array so that it can be used for the CNN model. For example, you can see in this picture, the train log image array is converted into the NumPy array. And the image on the right side here is show that I already logged all the image. And then this 150 times 150 is the image size that I use. So now I will talk about the model architecture. And this one is the model which overfitting. For example, it contains convolutional 2D layer, which first I'm using 1 to 8 filters, and then I'm using the max pooling layer to reduce the dimension of the feature maps. And then I'm using the convolutional layer again, but now I'm using the 256 filters, and then I'm using the max pooling 2D layer again. And then I'm using also the flatten layer to convert all the 2D arrays into a 1D vector. And then I'm using the hidden layer, which the dense layer, which contains a 1 to 8 neurons, and using the ReLU activation function. And then lastly, I'm using the dense layer, which is 200 output neurons, and I'm using the softmax activation function for this categorical classification. And then for the model architecture that I solved the overfitting problem, I using the this tool is the same, and I add a dropout layer. For the dropout layer, it ignores the random subset of units and randomly sets input units to 0. And also I also add the batch normalization layer, which keeps the mean output close to 0 and the output standard deviation close to 1. So later I will talk about the problems, about what's the overfitting issues and cause, and how to solve this problem. So now if you look at the results, you can see that these two pictures above is the accuracy and loss graph of the model which non-overfitting, which the overfit encounter overfitting issues. But the image below is the graph for the accuracy and loss for the models which does not encounter the overfitting issues. And then if you look at the results, for the overfitting model, the training is 58%, validation is 2%, and top one is 4%, 0.4%. But if the without overfitting issues, the training model is 2% only, validation is 0.8, and top one is 0.5% only. So now the problem is, if you look at these two different models, which the overfitting issue and the without overfitting issue, you can see that the overfitting issue there, is big difference between the training and the validation test, but without overfitting issue, it's slightly not so overfit. But so the cause, the overfit they encounter, is the model is too complex, too many features or labels, because there are 200 class or too little training data. The size of the training data set is not enough because there are 4,829 only, and too low bias and very high variance. And also there's a lot of noisy data or inaccurate data. So it may decrease the accuracy and increase the variance. So how to prevent it? I using a dropout for I present just now. I add the 3 dropout layers, 20%, 50%, 50% again. And also I add the batch normalization layer after the pooling layer. So now I will show the outputs for our code first. So this is my code. First, I got to preparing the data. Okay, I'm seeing the data. So I print the total number or train a test image. I do a normalization function. I release and also log the train test in the list. And after I log into it, I convert it into the array, and then I randomly show the image. Now, yes, it's here. So for the CNN architecture, the model architecture with overfitting problem is here. And then I using the top one accuracy and the accuracy evaluation metrics and model train it. And then this is the average, accuracy average. And this is the graph for the accuracy and loss graph. And for the without overfitting problem, it's all the same. I listen here. Also, I also comments of the layer or function I use it. Yeah. So I will briefly show about the report. For the report, I talk about data preparation, the steps. And so I compare between the two model architectures. And also, I also present the results. And so I discuss about the methods used, method to solve the overfitting problem, and also the which is better. Okay, so that's all for today's presentation. Thank you, Miss, for your kind attention. Thank you.